Okay, so this is the Chapter 7 review for geometry. Number 1, I'm supposed to solve for x. I need to figure out what kind of shape this is first. So this shape has 1, 2, 3, 4, 5 sides, making it a pentagon. I need to know, before I do the problem, I need to know how many degrees the interior angles on a pentagon will add up to. So I'll use the formula 180 times n minus 2. N stands for the number of sides, so this is 180 degrees times 5 minus 2, which is 180 times 3, which is 540 degrees. So all pentagons need to add up to 540 degrees. So now I'll add all the angles that they have given me, 72 plus 2x plus 99 plus 89 plus 3x equals 540 degrees. So combining like terms, 2x and 3x make 5x, 72 plus 89 plus 99 is 260, and that should still equal 540 degrees. Subtracting 260 from both sides, I will get 280, and dividing by 5, x is equal to 56. Number 2, these are all exterior angles. You can see because they're on the outside of the shape. And so all exterior angles of any polygon should add up to 360 degrees. So 94, 56, this clearly doesn't look like 4.5 degrees, but we'll just take it, plus x plus the 1.5x. All that should equal 360. So anytime we use exterior angles, angles on the outside of a shape, it's 360 degrees no matter what shape it is. So 94 plus 56 plus 4.5 is 154.5, x and 1.5x is 2.5x equals 360. Subtract 154.5 from both sides. And I get 2.5x, sorry, equals 205.5. Divide by 2.5, and I get x is 82.2. Excuse me. And number 3, I need to find the measures of the numbered angles for each parallelogram. So these are parallelograms. One of the properties of the parallelogram is the opposite angles are congruent. So if this is already 140, this is also 140, angle 2. Another property of parallelograms is consecutive angles supplementary. So these two angles are supplementary, these two angles are supplementary, these angles are supplementary, those angles are supplementary. So if I take 180, subtract 140, that gets me 40. So angle 1 has to be 40 to make this supplementary. And angle 3 is also 40 since opposite angles are equal to each other. Number 4 is very similar. Again, this is a parallelogram. Opposite sides are parallel. So I know that opposite angles should be equal to each other. So angle 1 has to be 113 degrees. A lot of people will think angle 2 is also 22 because this is 22. But that wouldn't make any sense because 22 plus 22 plus 113 is 157, and we all know triangles should be 180 degrees. So that doesn't, angle 2 is not 22. What happens here is what gets created because these parallel lines are these alternate interior angles here. And if lines are parallel, alternate interior angles are equal. So the angle that is 22 is angle 3. By the same reasoning, I can make alternate interior angles here, and angle 2 should be 45. I can check my work and I can add 45 plus 22 plus 113, and And that does equal 180 degrees. So for number 6, I have to decide just from the markings if those shapes are parallelograms. This one's a no, because for a parallelogram, opposite angles need to be congruent, and this one, the opposite angles are not congruent. This one's a yes. It's kind of obscure, but one of the conditions for you to be a parallelogram is to have one pair of sides equal and parallel. So that's a condition for you to be a parallelogram. And this one is a yes, because this part is equal to that part. Those are diagonals and they bisect each other. So yes, because diagonals bisect. Number 7, I would solve for x and y. I'm going to solve for x first. They only give me this angle here is 62. So I know these two angles are consecutive, and so they need to add up to 180. So 5x plus 3 plus the 62 has to equal 180. So our 5x plus 65 equals 180. 180 minus 65 is 115. And divide by 5 is x is 23. So I know these are supplementary, they would add up to 180. Angles across from each other, opposite angles, have to be equal to each other. So 3y plus 2 has to equal 62. Just subtract 2 from both sides. And divide by 3, I get y is equal to 20. So x is equal to 23, y is equal to 20. In number 8, ABCD is a parallelogram, and because it's a parallelogram, I know the diagonals should bisect each other. So this part of the diagonal should be equal to this part of the diagonal, and this part should be this part. Okay. A lot of people would just make x plus 1 equals to 2x because they both have x's. That's not always the case in geometry. You have to find the objects that are equal. X plus 1 has to equal y. I can't really do anything with that. I can't solve that by its own. So let me try the other equation. 3y minus 7 equals 2x. I can't solve that equation either by itself. What I can do is use substitution. Notice how the first equation is equal to y. So I'm going to take that x plus 1 and I'm going to substitute it. I'm going to substitute it in for y because that's what it equals. I'll rewrite the whole second equation over again. 3. Instead of y, I write x plus 1. Minus 7 equals 2x. Distributing, that's 3x plus 3 minus 7 equals 2x. This is 3x minus 4 equals 2x. Let's subtract 3x. I get negative 4 equals negative x, or x is equal to 4. And in the top equation, x plus 1 equals y. If I have that x is equal to 4, I can substitute the 4 in for x, and I get that y is equal to 5. So number 9, it tells me that shape is a rhombus. I'm supposed to find the length on each side. By definition, a rhombus has 4 equal sides. So this side is equal to this side, and that side. So 9a minus 18 has to equal 3a plus 15. Subtracting 3a, 6a minus 18 equals 15. Adding 18, 6a is 33. So a, when you divide both sides by 6, is 5.5. They didn't want just what a was equal to, they wanted to find the length on each side. So I need to substitute that back in. I can pick any one of these since all of them are the same. 3 times 5.5 plus 15 is 31.5. All the sides are 31.5. Okay, so on number 10, this is also a rhombus, I need to find the measure of all the angles. Okay, so I need to figure out angle 1, angle 2, angle 3, angle 4, and angle 5. So one of the properties of a rhombus is that the diagonals, not only do they bisect each other, but they meet they're perpendicular, so they meet each other at 90 degrees. So anytime you see a rhombus, you can draw that in, and you can see that angle 4 is 90 degrees. So I can use that idea to figure out angle 1. And that makes a right triangle here. So 90 plus 26 is 116. I'll subtract that from 180, and that's 64. So angle 1 is 64. If you see, like in this rhombus, I could fold this bottom triangle over to this one over here. You can see that angle 1 and angle 2 should be the exact same. So angle 2 also is 64. If I folded the triangles over this way, you can see that 1 and 5 should be exactly the same. So angle 5 is also 64 degrees. I can't fold anything onto angle 3. If I just folded it this way, nothing would go in there. Except I know this angle that's 26 should be equal to this angle that's also 26. And then I can fold that over and I get that angle 3 is also 26 degrees. On number 11, just to find the length of HJ. HJ is a diagonal. And in a rectangle, the diagonals are congruent. So HJ, which is 3x plus 9, should be equal to 5x plus 5. The other diagonal, IK. Solving this, subtracting 3x, and subtracting 5, I can get that x is equal to 2. I need to find the length of HJ, which is 3x plus 9. And I go substitute 3 times 2 plus 9. That is 6 plus 9, which is 15. Both diagonals would be the length of 15. Number 12, I have a kite. In a kite, I know that there is 2 pairs of congruent sides that are not opposite. So like AB, they tell me, sorry, AB should be equal to AD, and BC should be equal to DC. They tell me AB is 5x minus 7, BC is 160, CD is 160, and DA is 3x plus 29. So those 2 sides should be equal. These 2 sides are already equal. So 3x plus 29 has to equal 5x minus 7. Okay, subtracting 3x and adding 7, 36 equals 2x. Dividing by 2, I get that x is equal to 18. Okay, so I need to find the measure of DA. DA is 3x plus 29. So 3 times 18 plus 29 is 83. So this is an isosceles trapezoid. These are the 2 parallel bases. And these are the base angles, here and here. And if it's isosceles, these 2 base angles should be congruent. And these 2 base angles should be congruent. So I can automatically see that angle 2 is 62 degrees because those base angles should be equal. Now if this is 62, and that's angle 1, these two are equal here. I notice these are same side interior angles. These have to be supplementary. So if I take 180 minus the 62, that should be congruent or equal to angle 1. Angle 1 is 118 degrees. In 14, I'm using the same idea. Angle H is 8x. Angle G is 10x minus 38. If this is going to be an isosceles trapezoid, then those two need to be equal to each other. So 8x should equal 10x minus 38. Subtract 10x. That's negative 2x equals negative 38. And x should equal 19. On 15, I'm supposed to graph these points and prove or disprove that these are parallelograms. And there's a couple ways to do that. That's A, B, C, and D. There's a couple ways to do that. We know that on a parallelogram, the opposite sides are congruent, so you could show that AB is equal to DC by using the distance formula, showing them they're equal, and also BC is equal to AD. But I'm just going to use the definition of a parallelogram, which says the opposite sides need to be parallel. So I need to compare if AB is parallel to DC. And to do that, I need to find their slopes. If they have the exact same slope, then the two shapes are parallel. I mean, the two lines are parallel. So to find the slope, I need the rise over run from A to B. So to get from A to B, I have to go down 2 units. So that's a negative 2 rise over run for slope. And then a run of 1, 2, 3, 4, 5, 6, which reduces to negative 1/3. Slope on DC, going from D to C, down 2. Okay, so negative 2, and to the right, 1, 2, 3, 4, 5, 6. You can see I end up with the exact same slope, and so yes, AB is parallel to DC. And I need to check the other sides as well. I need to compare AD with BC. I need to check to see if they're parallel. AD, the slope on AD is down 1, 2, 3, 4 over 2, which reduces to negative 2. And B to C, down 1, 2, 3, 4, and over 2, also negative 2. So these sides are also parallel as well. So this is a parallelogram because both pairs of opposite sides are parallel. On 16, this is another isosceles trapezoid. I need to find the measure of angle W. So a lot of people will be tempted to make this congruent to that, like equal to that. This one's obtuse, this one's acute. It doesn't make sense for those to be congruent. What I do know is that this angle is equal to this angle, right? I can write an 8x minus 11 there. And that will create, since these are parallel, if this is a trapezoid, that'll create same side interior angles here, where these have to add up to 180. So 8 and 16 is 24, 25 and 11 is 36. I'll add 36 to 180. So it's 24x equals 116. Divide by 24. Oops, hold on, let me do that again. Yeah. 116 divided by 24 is a decimal, which is not nice. repeating. So let me just check my work. 16 plus 8, that is 24. Negative 25 plus negative 11 is negative 36, and they should add to equal 180. 180 plus 36 is 216. That's where my mistake went. 216 divided by 24 is 9. X is equal to 9. We need to figure out angle W. So we established that these two should be equal, so I can substitute 9 in for 8x plus 11, or minus 11. 8 times 9 minus 11 is 61 degrees. So for 17, I need to find the length of the mid-segment. That is this point that connects two midpoints on a trapezoid. So the mid-segment is the length that's exactly in between 39 and 13. So to find the exact middle, you find the average. You add them up and divide by 2. 39 plus 13 is 52, divide by 2 is 26. So the length of the mid-segment is 26. So for 18, I need to mark any congruent sides or angles, parallel sides or right angles or anything like that, and put diagonal marks. So this is, starting off, this is a kite. I know that in a kite, there are two pairs of equal sides. They're just not opposite sides. So they're not equal this way. They're equal this way. On a kite, these angles should be equal to each other. Okay. Those have equal angles. They don't have any parallel lines. If I do diagonals for these kites, diagonals don't bisect or anything, except this part of the diagonal is equal to this part of the diagonal. And all kites' diagonals intersect at 90 degrees, so the diagonals are perpendicular to each other. And I think that's it for a kite. For rhombus, by definition, all the sides are equal. It's a parallelogram, so opposite sides are equal. Parallel, sorry. In a rhombus, the opposite angles are equal because it's a parallelogram, so this angle is equal to this angle, and this angle is equal to that angle. Diagonals are perpendicular, so there are 90-degree angles in here, and because it's a parallelogram, diagonals bisect. Like this part of the diagonal is equal to this part of the diagonal, and this part of the diagonal is equal to that part of the diagonal. In an isosceles trapezoid, to be a trapezoid, you only have one pair of parallel sides like that. To be isosceles, you have two equal sides. Because of that, those equal sides, you have these base angles being congruent, equal, and these angles being equal. And on top of that, the very last thing about trapezoids is the diagonals do not bisect. You see, like they don't have equal parts this way, but the diagonals are also congruent. And that's pretty much everything on that. So in the last part, I have to determine if the statement is true or false. The opposite angles of a parallelogram are congruent. That's true. That's one of the properties of a parallelogram. The opposite sides of a trapezoid are congruent. Here are sides of a trapezoid. They are not congruent. They are parallel. So that is false. To make it true, they should have used the word parallel. A rectangle is always a square. That is false. A square is always a rectangle. A rectangle has 4 right angles. That is definitely true. That's the definition of a rectangle. A parallelogram has always has 4 congruent sides. That's false. It doesn't always, and sometimes, if it is a rhombus. The diagonals of a rectangle always bisect each other. That is true because a diagonal is a parallelogram, and this is diagonals of a parallelogram are always bisecting each other.